Okay, and we're continuing on with the fourth and final part of this little rebuilding surface exercise. So where we've gotten is we've got these two nice rebuilt wall surfaces that come down to a sharp intersection, but are very clean, and they actually extend out past the edge of our solid quite a ways, which is great. We do have some areas here where the surfaces extend out probably past where the actual material lays. So if we look at, this stock model here, really kind of, if it's created correctly, should be showing, where that geometry is. Looks like it's off just a little bit. But that's okay. So what we have now is this set of surfaces, including our choice of different fillet radii down at the bottom. This one at 053 being kind of optimized for this 093 end mill to allow it to not go down to a sharp point. Otherwise, we could use this 035 to let it go down to a sharp point. So let's look at how do we create the best tool path for this. So we could use blend, for example, and we could use these as our blend curves. We could try an equal scallop toolpath. I think, either of those would work fairly well. But the best results that I found were actually going old school with an older path, and that is surface finish contour. So part of what ends up happening, and we can look at this unified morph as a good example. Let me just there we go. Let's look just at the path itself. And if I go under toolpaths and turn on my advanced toolpath button, advanced display, I think is what they call it, I've got my endpoints turned on. And so now you can see, the path itself, lots of problems, right? But part of the issue is the shape of the geometry. If we go into backplot and we start looking at it, you can see, like, if I look at this from the right-hand side, the tool following the surface naturally is starting to assume that shape of that floor, which means none of these are going to be arcs. At best, they're going to be some short line segments, and that's what's going to give us, the repeating of these lines over and over and over as it kind of drives down those surfaces is going to produce our shape. But it's not going to make for very efficient code. You can see right now we've got 821.9 kilobytes of data just for that one little path. So let's get out of there. Let's go back and turn on our new surfaces and our boundary. So that's what we're going to work with here. And let's look first at the finishing path. So I'm going to right click, do a mill toolpaths, surface finish, contour. And it's going to ask me for which surfaces do I want to select. I'm going to select those three, the two walls and this 053 radius, and hit end selection. So if I do drive surface show, by the way, it'll just show me the ones that are selected, which is very handy. And you can give it an approximate start point if you want. I would recommend, the top or bottom of that slot, because that should be the point at which it kind of drops down to approach those surfaces. And let's go. So we'll say, okay, we get the old school dialogue. This path isn't super fancy, but it has a lot of control over it. So let's uh, let's do some adjustments here. So surface parameters, let's just say that this here is the actual finished path. I always set my retract and my feed plane to be incremental when I'm surfacing. This is incremental from the depth of the surface geometry. This is not incremental like we're going in from absolute to, from G90 to G91. And I'll set a clearance plane at 2 inches incremental because I want a point that's going to start above the path. It's going to wrap it down to kind of where we're actually starting the feeding from, and then it's going to go and start cutting the part. I will set this to center for the boundary for now, and we'll see if we need to set it to inside. Actually, you know what? Let's do inside. We'll set it to stay inside the boundary and see what we can get. Maximum step down. I'm going to put 30 thousandths for now. I'm going to tighten that up in a little bit, but in order to make it calculate quickly, I'm going to set it to 30 thousandths. Don't need to worry about the entry exit arc, any of that stuff. I do for closed contouring, want it to cut climb. For open contours, we're going to say one way. We want to try and keep this climb milling, and there's a good technique for us to do that. So total tolerance, let's fix this first. Because we're doing planar slices and we're running contouring passes, we really want to use the line arc filter and not use smoothing settings. So I'm going to turn the line arc on. I'm going to set it to G17. Minimum arc size. I mean, we know that the radius here, let's do the smallest radius. That's 53 thou there. We'll set our minimum arc radius to say 15 thousandths of an inch. And let's set the maximum to, 5 or 10 inches. Let's do 10. I always adjust these values to be more representative of the actual shape and size of shape that I'm cutting. And then for split, let's do cut tolerance at 20%, which means we want it nice and accurate, 2/10 accuracy. And then we allow all the rest of this size to give us our arc filtering. I'm also going to tighten the arc filtering. In other words, out of this total tolerance, I want it to use most of the tolerance for generating arcs. So we're going to give it some parameters here, see what that gives us, and I'll select OK. Center was not the way to go. Let's make sure we're set to inside. Oh, we are set to inside, but we don't have a boundary. That's the problem. So we need a containment. Let me make sure I'm in full chain mode. There we go. There's our boundary. And problem 1 solved. Ha. So this is looking okay. Remember, we're driving to this lower fillet radius. So what I'll do, I'm going to take this bigger radius and let's move this to 14. And this is going to be 0.07 floor radius. So we'll move it, turn off the visibility. Okay, that's looking a little better. We know for sure we don't want to let it drop off the end there. So what I'll do, I'm going to make sure we're in front view, front plane. I'm going to set my Z depth to the edge there, which should be 4.28. And now I'm going to make it 4.0. Actually, let me do this. I'll right click, I'll select the Z depth button, and I want to choose this endpoint on the surface. So I can hit E, and it'll actually find the endpoint on a surface, and that's at Z 4.0. That's probably good right there. So we'll make it, I was right, Z 4 inches is a good value. So now what I'm going to do, make sure we're in 2D mode. I'm going to go into wireframe, line endpoints, and I'll do E and E, and I'll do E here and E here. And if I look at this in the front view, I'm not super happy with that. We're going to go off the edges of these surfaces here. So endpoint, we're going to do E on the surface. Oop, let's do this. Hide everything else. I'm going to do line endpoint. Oop. Okay, so what I'll do here, I'm going to create a curve on one edge, create a curve on one edge, do that. Those should be lines. Let's make sure. Okay, so they do meet at the same peak, at the same point, which is good. You know, I know the better way to do this. Instead of doing this off the surface, let's get our solid back. So turn the solid back on, do a line endpoint. We'll do one from here to here, and we'll do one from here to, here to here. Okay, so make sure we're in the front plane, which we are. Let's go look at this in the front view. I'm now going to translate this, and I'm going to set it to move, and we're going to go Y 20 thousandths, and I'll do apply. That's the move. And now we're going to do this one again as a copy, and I'll go, say, 0.2. That looks pretty good. Apply. I'm going to grab that line. We're going to go minus 0.02, move it, apply, grab it again, minus 0.2, copy, OK. And I'm going to do modify length 0.2. Okay, so what I've done here is I've just created some lines so that I can create a surface. Okay, and now I prefer to do this visually. I can do a translate, and I can move it up in Z. That looks pretty good. So what I'm doing is I'm creating a check surface. So let's clear that. And let's set this to some kind of red, like that. All right, so now we've got this place where our toolpath is kind of diving in because of our boundary, right? So our boundary's up above, and I'm just using Alt-E, Alt-Echo on the keyboard to set that. So now I can go back into this surface finish contour. I can add those surfaces as check surfaces. And I can select OK. It's going to give me a warning about the drive and check surface, etc., etc. Okay. So a couple of more things that we can fix. So number one, do you see how this tool is trying to run around the outside edge of the surface to hit the boundary? So with Surface Finish Contour, we can control that behavior. That is under Advanced Settings, only between surfaces. So at the surface or solid face edge, roll the tool only between the surfaces. So automatic will really kill you with this kind of toolpath. I'm also going to turn off check for internal sharp corner. So I'll select OK. It's going to give me a warning when I generate, but it's also going to give me this really nice, clean path that does not go beyond the edge here. So a couple of more things I can clean up. So first thing we're going to do to clean up is follow surfaces. So instead of this little jagged, broken step down here, we can use follow surfaces, and we're going to get this nice, clean, smooth motion. We're still getting some jumps over here. So wouldn't it be nice if we could just connect those with this nice, smooth curve? Well, it turns out we can. So in the surface finish contour parameters here, I'm going to go to gap settings. And what gap settings allow us to do, it says retract if the step over or step down is greater than, right now it's 300% of max step down. So this is always going to vary. As my step down varies, 300% of 30 thou is 90 thou, right? I'm just going to change this and say, hey, if it's retract if the gap is bigger than 200 thousandths. Let's see if that gets us a great path. That's getting darn close. Looks like we've got one entry here, we've got one exit here, and we've got one gap that's bigger. So let's go in there and do gap settings, set it to 300 thou. That's looking pretty good. So what we've got now is this toolpath that just drops in, stays down on the surface, and keeps cutting. Now, where we have it set to stay inside, you'll notice it's keeping the tool inside that boundary instead of center to the boundary. But as I step along here, what you may notice is that we're actually off of that surface. And that's especially true here. And so we could, with some of the other toolpaths, we could use stock as a way to tell it exactly where to cut. We can't really do that with this one. And we still do have this kind of sharp transition line. It's not the end of the world. It looks better once we get down into that fillet radius here. I mean, that's pretty nice motion. And now we can adjust the step down, right? We did a nice, easy 30 thou step down for the calculation. We can now go in here and make this 10 thou. Say OK. But what we're probably going to end up with, yep, we have all these extra passes now, especially kind of up at the top. So you can see that it barely makes a pass here. Barely makes a pass, and we're up above the geometry completely. So it barely makes a pass, does this weird kind of little step. Now it gets down to where it's actually cutting. But really, the first couple of passes, and this will be even more obvious, for example, if I take just the gear and hide everything else, and now we do a back plot, kind of from scratch, from the top. Let's actually look at this from the top. So those first 2, 3, 4 passes maybe really aren't even hitting anything. And even if if I pass it here, okay, we're probably down on that surface. You know, if I jump up to the third pass, we're not really on that surface. But this is good because there's a technique, there's a tool in the surface finish contour toolpaths called cut depths. So I can go into cut depths and I can use this. This is really counterintuitive. If I do, for example, minus 50 thousandths incremental adjustment to top cut, you'll notice nothing really changes because the negative value actually goes up. If I go down, on the other hand, it's a positive number. We're pushing it into the surface. We're pushing the start. So you can see if I do that before I regenerate, here's the current start. So now I've used that cut depths to eliminate the first set of top passes by telling it, you know what, go ahead and start 50 thousandths deeper. And it looks like that's probably pretty good for contact. That first pass, nice right there on the tangent of the ball. So that's probably a good starting depth. If it's still too high, I can push it deeper. And we know, here's, let me just align it so that that pass is right at the top edge visually. So we know that's where it was, right? If I go back in here and say, okay, cut depths 0.06, you can see it actually dropped that starting pass. So now we're starting a little more down there, but still should be in a good spot. And there's, you can verify this, you can run it through and look at the material that way. But this is going to give us such a nice, clean toolpath. It's 80 kilobytes. So versus 821, 822 kilobytes, it's literally 1/10 the size. So here you can see now we're doing this, it's not spiral, it is planar, but it's almost this spiral style motion where it's just, feeding down along that surface. It's going to create a great looking surface. Okay, so this very clearly demonstrates what I think of as a superior toolpath. A superior toolpath really to me is any toolpath where in a single toolpath, you've designed the tool motion to give you one entry point at the start and one exit point at the end, and the tool has kind of stayed down using the style of motion you want. Now, there are some options in here. For example, use plunge and retract rates in transition motion. So this is a great one under toolpaths. So I could make this, for example, 200, and I could make the retract rate 200, and we can actually leave on rapid retract because we've only got one retract at the end. And when I backplot this, expand this dialog a little bit. Okay, so here we are, plunges down, plunged in at 200 inches a minute. What don't we have there? Well, we don't have any actual material. So we planned it out so we're feeding down off of the part itself. And now as we step in, you can see it actually went to the real feed rate, 26.88. And we're going across there. It should be using that transition motion. So it doesn't necessarily always work. But sometimes it does. Oh, and this may be because we're not actually retracting. This may only apply if it's to the retract move versus the keep tool down on the surface transition move. So thought I could do something cool there. Guess not. The other thing that we could potentially do, again, if we were kind of looking for the smoothest transition possible, we could try a blend surface. So we could go in there and save it. Let's do a surface, and we'll do a 2-surface blend. Select a surface. I grab that edge, select a surface, grabs that edge, and we'll say enter when you are done. So start magnitude on surface 1 looks pretty good. Let's go opposite. Ooh, defined. Let's go opposite there. Let's turn off trim surfaces. Turn off keep curves. Yeah, so if I go to 0, let's see if I can go to -1. That looks a little better. So part of it could be because we're coming to that sharp corner. So -2. Ooh. Let's try this again. So 2-surface blend. And it's grabbing those 2 edges. That's good. Enter when you are done. Let's go 2, 2. So I've set that start and end magnitude to 2, which has given me kind of a nice blend of what I'm really trying to achieve. 2 might be a little bit too much. We could always try like 1.8. 1.8, that's pretty good there. Let's try minus 1.8, and this is generally speaking, and I'm speaking in very general terms, I know that's kind of an oxymoron, a scale from plus or minus 2. So we'll try 1.5, 1.5, minus, and we'll try positive 1.5, 1.5. And what I'm looking here is, what does the shape of that blending look like? And you know, it's gotta do this weird thing where you've got these upsweeping curves meeting this radius, right? So that's a pretty good approximation in my world of what that surface might look like. So I'll do apply. Let's do another one over here. That's good. This line to that line, we say OK. Enter when done. And we just reverse them. So this is minus 1.5, minus 1.5, 1.5, 1.5. And does it do as good a job? Maybe not. Let's zoom in and evaluate a little bit. It's kind of more truncated. It's not nice and round. So to make it more round, we're going to do this. Is that round enough? Do we need to go to 2? Minus 2, minus 2, 2, 2. I think that's better. I think that